welcome everyone to this interview with Sam Cree. He's a physics graduate from UQ just a couple of years ago. So his path is of interest to any physics research students who are interested in a career in research. So Sam, why don't you tell me a little bit about yourself and your path to doing a PhD at Stanford?
Yeah, sure. So I guess I'll start with my original degree at UQ, which was a dual degree in Bachelor of Science and Arts. And I did that because I wanted a lot of flexibility when I started out. I actually started off with courses in physics, maths, political science, and philosophy. And yeah, over the course of my degree, I changed a few times what my official program was. I changed to Bachelor of Maths, Bachelor of Science when the Bachelor of Maths was introduced. And then in my fourth year of that program, which was the final year, towards the end of semester one, I had a very last minute decision to graduate a semester early with just a Bachelor of Science, majoring in physics and mathematics. I was aware that I wanted to do a postgraduate program in the Northern Hemisphere, and the scheduling is kind of unfortunate for the usual timeline of graduating from Australia, because you graduate in November and
you have
anywhere you want to go to.
You have that
Exactly.
8-month gap, yeah.
Yeah. Anyway, if you want to do a program in North America or Europe, then it's likely to start in September. And so you've kind of got basically 10 months of this awkward in-between phase.
But finishing in June/July is very ideal for going to start in the Northern Hemisphere.
Yeah. I did my honours second half of 2017, first half of 2018. I then, went to a master's program in Canada called Perimeter Scholars International, which is a 1-year master's in theoretical physics. And that was really useful for me to kind of bridge the gap to a PhD program, because for one thing, I wasn't yet sure what area I wanted to study in within physics. And so this was like a broad coursework program, which meant I didn't have to pick a field yet. I didn't have to commit to a particular topic. And I was really scared by the prospect of committing to a particular thing. And the other thing it helped with was I was kind of unprepared for the process of applying to the US. I didn't realize that there was a standard exam that you have to take for a lot of places in the US.
The GRE?
The GRE, yeah. I didn't know about that when I was doing my honors. And so I actually missed the deadlines to take that exam.
Right.
If you're planning, for example, to start your PhD halfway through 2021, then you would need to be looking now into GREs, because there's deadlines in August or September. It's ridiculous how far ahead you have to.
These are deadlines to take it in Australia, is it?
These are deadlines to sign up for taking it in Australia. That's right. Yeah. So, and some of them are not, well, none of them, as far as I'm aware, are offered in Brisbane. At least they weren't when I went through this process. So
you need to travel.
You have to look into travel to Sydney and Canberra. It's pretty frustrating.
Yeah, some of the institutions you went to are pretty prestigious. So Perimeter Institute and Stanford. And I know you've got quite an impressive record. So your honours was published. You won the Bok Prize and got accepted into master's degree from Perimeter Institute. So what does it take to be accepted into these highly prestigious institutions? For example, Perimeter Institute and Stanford, which do have really low acceptance rates, when surely straight 7s aren't enough to get into these places.
Yeah, that's tricky. I think luck certainly plays a significant role, and that's a strange thing in a way, because you'd like to think that it's in your control to you'd like to think that if you check all the boxes and do all the things that you're supposed to do, then you'll get in. But it's part of it comes down to the fact that I was given a very interesting project for my honors, and it turned out to lead somewhere, which need not have been the case. And I see that as being partly luck. Yeah, and like the admissions processes for a lot of these places are just a mysterious black box
Yeah.
where like you put in all your hard work to try to optimize everything you can, and then out comes an acceptance or a rejection email,
and it's
no
like
one really knows.
2 to 4% of people that put it and get
yeah, I mean, some places are pretty low percentages like that, and I think that the people doing the admissions have a hard time as well, like finding some reasonable, fair-ish kind of way to make those decisions. So yeah, on the one hand, I think the fact that a lot of it is luck is kind of a motivation to give things a shot, and to it means that like the more things you apply to, the more likely you'll get in somewhere. And so that's one thing you can do to control it, is just shoot your shot at as many places as you can.
Right. So bulk applications in combination with, throughout your undergraduate degree, any opportunities you might get, taking them. And
yeah. And sorry, there are certainly things you can do to improve your chances. It's not pure chance. Doing as much research as you can in your undergraduate is probably the biggest thing, I think, that will make a difference. Getting good grades will help as well. The other side of the coin that it's largely luck based is if you don't get in, it doesn't mean that it's a reflection on you being a bad scientist. It means to some extent you were unlucky. So don't let it get to you too much, because that can be a really, it can be a tough experience. And, so when I applied to places in the US, Stanford was the only one that I got into out of about 8 places. And I should also acknowledge, like, I've been incredibly privileged and fortunate in many ways. And the fact that I could afford the application fees for 8 different universities means that, my financial position is part of why I managed to get in. And that sucks, but that's part of how these things work. And, it's also something to think about.
So coming back to your research, your paper was very interesting. I had a bit of a breeze through it myself.
Thanks.
What sort of research are you interested in now? Are you still focused on the cosmological constant problem, or have you branched out into other areas for your PhD?
I've moved away from that a bit. I really enjoyed that work, and this is something that I would consider recommending. Is like, I mean, obviously take everything with a grain of salt. I am one person, and my experiences don't speak for everyone. But like, I found it really useful for honors to be like, okay, this is 1 year. In the grand scheme of things, it's not a huge commitment to pick something to study for that. So I chose to do something that to me was a bit more out there and a bit more adventurous. And that's what this project I did for my honors kind of represented, was something a little bit more like, I don't know, abstract and disconnected from other areas of physics. So it was lots of fun, but I kind of, from when I started doing my master's and my PhD, I kind of wanted to move more towards some mainstream areas of study, because that is something you kind of have to think about if you want to stay in academia. I just realized I didn't really answer your previous question yet. I've moved towards quantum information theory, which has been really fun. So it's kind of, the way I like to think of it is, there's been a lot of study in the last couple of decades about quantum computing, and kind of the theoretical underpinning for that has really changed how we think about quantum physics itself. So what's a really trendy thing to do right now is take ideas from quantum computing and ideas that have been developed for it, and apply it to other areas of physics. So trying to understand, like, what is the role that entanglement plays in complicated interacting systems of particles, and how does entanglement help us to understand quantum gravity as well, and black holes? And those are the kinds of questions I'm really interested in right now. So trying to learn a lot about quantum information theory, which is kind of this interesting intersection of physics, mathematics, and a little bit of computer science even.
So do you want to stay in quantum information once you get your PhD?
I'd like to stay. I think that one of the things I really like about quantum information is you can kind of interact with lots of other fields, because it's very interdisciplinary. And so right now I'm doing quantum information that has connections to black holes and quantum gravity, but I'd like to move towards other applications of quantum information after my PhD that might be a little bit more tangible and a little bit more like real world.
It's a very interesting area because you can have those practical applications to it which will get grant funding, but then you can also have side projects which are very interesting, like looking at black holes.
It's a cool way to kind of get to do a little bit of each.
So what sort of extracurricular activities did you do at UQ, and did you think these were important for your application to grad school?
I did a few. So one thing that I really enjoyed was being involved with the clubs and societies at UQ. So I was the president of the physics club for a year, PAIN, which was a lot of fun. It was a lot of work. It was rewarding though. And I think that played a role in helping me with my US applications. As I said, it's a black box. It's a mystery and I don't really know. So I can't tell you confidently what it was that meant that I got lucky, or what factors helped me with that luck. But I enjoyed that for its own sake though. And it was really, fun and rewarding to try to think about how to make the undergraduate experience better for other physics students and how we could kind of accommodate that through the clubs and societies. UQ has some good opportunities for science communication. So the science demo troupe is a lot of fun. You can go and present to different high schools, do science demonstrations that have some kind of, fun, engaging presentation of a scientific idea, often involving like liquid nitrogen or balloons or a Tesla coil or things like that.
I think that covers just about everything. So thank you for your time today.